Okay, so today we're going to look at synthetic division. On your notes, you'll notice that I do have long division, which is another way to divide a polynomial. However, long division, it's a lot more work and we're just not going to worry about it. So we are just going to look at synthetic division today. So synthetic division is kind of a shortcut that we can use to divide a polynomial. So we're going to divide this polynomial synthetically. The first thing I'm going to do is collect like terms with my polynomial. So I have 5x squared minus x minus 6. So when I use synthetic division, I am going to take the 0 of my factor. So the 0 of this factor would be negative 2. And now what I'm going to do is I'm going to make sure that my polynomial is written in decreasing order, that the degree is written in decreasing order. I'm also going to make sure that I'm not missing any terms when my degree is written in decreasing order. For example, if I had 5x squared minus 6, I'd be missing that x term, and I would actually need to put a 0 placeholder, which we'll get to later. So now what we're going to do is that we have our polynomial in decreasing order. We're going to take the coefficients in front of from each one of these terms, as well as the constant. We are going to carry down the 5, and then we're going to end up multiplying. So negative 2 times 5 gives me negative 10. Okay. I'm also going to end up adding these terms. Negative 1 plus negative 10 gives me negative 11. Negative 2 times negative 11 gives me positive 22. Negative 6 plus 22 gives me a positive 16. So now what's going to happen is this last little slot here, this is my remainder. Okay, and then here, my 5 and negative 11, those are going to be the coefficients and the constant, okay, of my quotient. So what I've done with synthetic division is I've taken this original polynomial of 5x squared minus x minus 6, and I've divided x plus 2 out of it. So in other words, my polynomial, okay, should equal my quotient times my divisor plus my remainder. So if you're ever unsure if you did this correctly, okay, you could actually graph this new equation here, and you should see that it's the exact same in the equation as the one you started with. It's just written in a different format. Okay, so this just shows you the difference between long division and synthetic division. Again, long division in Math 30-1, we really don't need to worry about that. Okay. What we're going to do now is we're going to synthetically divide a few more examples here. So we'll start off and take our 0 of x minus 2. So my 0 would be 2. And then I'll take each coefficient. So my coefficient here is 1, negative 7, 11. Notice how this polynomial is already written in descending order in accordance to degree, and there's also no terms missing, so I don't need to put a 0 placeholder in. I'm going to carry down my 1 and then multiply. So 2 times 1 is 2. Okay. Negative 7 plus 2 is negative 5. 2 times negative 5 is negative 10. 11 minus 10, or 11 plus negative 10, gives me a positive 1. So in this case, again, this last slot is my remainder. Okay. So I would end up with x minus 5 with a remainder of 1. So my remainder is 1. Okay. My next one. So here we notice that we are missing a term. We're missing an x here. So when I go to divide, again, I'm going to take my 0 of the factor. I have a coefficient of 1, coefficient of negative 2, coefficient of 3, and then that missing term, that x, where the x would be, I'm going to put what we call a 0 placeholder in, and then a negative 8. All right, and then it's the exact same thing. I'm going to carry down that 1, multiply. 2 times 1 gives me 2, and then add. Negative 2 plus 2 gives me 0. 2 times 0 gives me 0. 3 plus 0 gives me 3. 2 times 3 gives me 6. 0 plus 6 gives me 6. 2 times 6 gives me 12. And then my remainder in this case is 4. So I'm going to end up with x to the third plus, we don't need to put a 0x squared, so we'll skip that, plus the 3x plus 6 with a remainder of 4. So another way you can actually check to see if that you use synthetic division, and actually probably a faster way, is what we call the remainder theorem. So with the remainder theorem, actually all you end up doing is you take the 0 of your factor, okay, and then you just plug it into the polynomial. So the 0 of x minus 2 again is 2, and then I'm just going to plug it in to my polynomial. I will type that in my calculator. So 2 squared minus 7 times 2 plus 11 should give me 1. Notice how my remainder matches the remainder that I had when I used synthetic division. I can do the same thing for the second example over here. So again, I'll use a 2. I'll plug it into my polynomial. So I have 2 to the power 4 minus 2, 2/3 plus 3, 2 squared minus 8. Okay, and once again, I'll type that in my calculator, and I should end up with a remainder of 4, which again matches the remainder that I had using synthetic division. Okay, so here's a little more division. So again, I'll take the 0. So my 0 of x minus 2 is 2. I'm not missing any terms here, which is great, so I don't need to put a 0 placeholder in. I'll carry down that 5. 2 times 5 gives me 10. 7 plus 10 gives me 17. 2 times 17 gives me 34. And negative 4 plus 34 gives me a remainder of 30. Okay, so I end up with a quotient of 5x plus 17 with a remainder of 30. All right, now let's try this one over here. So my remainder would be, or my 0, sorry, of the factor x plus 1 is negative 1. I will take the leading coefficients. I'm going to check and see if I'm missing any terms. No, so I do not need a 0 placeholder. Negative 1 times 2 is negative 2. 4 plus negative 2 gives me positive 2. Negative 1 times 2 gives me negative 2. Negative 5 plus negative 2 is negative 7. Negative 1 times negative 7 gives me positive 7 with a remainder of 1. So the quotient of my divisional statement here ends up being 2x squared plus 2x minus 7 with a remainder of 1. So just a quick side note, sometimes you might see, and I'm going to use this first example here, you might see synthetic division where they subtract instead of add. So if you were to subtract, and I won't go through the whole thing here, okay, you actually wouldn't take the 0, you would just use the sign that you see on the factor. I find that kids are more successful with adding, they make less mistakes with adding, so this is why you'll see I've shown it this way. Okay, so when 2x to the third minus 4x squared plus ax plus 3 is divided by x minus 2, or x plus 2, the remainder is 3. Determine the value of a. So obviously there's lots of different ways that we could do this. When we are given a remainder, instead of using synthetic division, your best bet is to use the remainder theorem. That is the easiest way to do this question. So I take the 0 of my factor. So the 0 of the factor x plus 2 is obviously negative 2. And I'm just going to substitute that into my polynomial. So I have 2 times negative 2 to the power of 3 minus 4 times negative 2 squared plus ax. Oh, sorry, my x is actually negative 2. Let me write that in there. Plus 3. And then we know in this case our remainder is 3, so we're just going to make this equation equal to 3. Okay, so I have negative 2 to the third, that gives me negative 8, times 2 gives me negative 16. Okay, minus 16 minus 2a plus 3. So I'll just go ahead and collect like terms here, and I'll end up with negative 2a minus 29 when I do that. All right, I'll bring the 29 over, so I'm going to add it on over here, and I'll end up with 32, which equals my negative 2a. And then I can divide the negative 2a, or the negative 2, which ends up giving me an a value of negative 16. Okay, so that is it when it comes to synthetic division and the remainder theorem. I definitely suggest you practice this. Do not worry about long division. Don't do long division. All right.